Hey guys, this is binarybytes, and welcome to another lecture in Precalculus. Today we're going to go over some of the applications of solving general linear equations. This is what math is all about. It's about taking words in physical reality and transcribing them into quantitative terms. So we want to be able to solve problems that exist in real life. And to do that, we have to be able to describe it in a mathematical sense. So this is going to help you really cultivate that understanding and learn how to do that from simple examples. And we're going to work up to harder ones over time. But let's get this started. So before we do any of this, make sure you try these questions out yourself. They're kind of puzzles and they're pretty fun. And if you try it yourself, if you get stuck, come back, try it yourself, and then just check the answer with me. That's how you want to learn. Math, physics, computer science, all of these things, all the technical skills you can only accrue by doing and not by watching. So I'm here to help you as much as I can, but don't just passively watch me. Make sure you are trying it yourself. So let's get started. Carmen is 12 years older than David, and 5 years ago, the sum of their ages was 28. How old are they now? So what we're looking for is to find how old Carmen is and how old David is, which means there's two unknowns. So C for Carmen and D is equal to David. So let's see what this is describing. Carmen is 12 years older than David. It means that Carmen is David plus 12. And 5 years ago, the sum of their ages was 28, which means that C minus 5 plus D minus 5 was equal to 28. So these are now two separate equations. Equation number 1, equation number 2. One of the common methods of solving equations with two variables like this, two unknowns, if you have two unknowns and two equations, that's called a system of equations. System of equations. If you have two unknowns and two variables, you can solve it. So all you have to do is do something called substitution. So let's see what this says. It says C is equal to D plus 12. So C is already isolated, which means we can go into number 2, equation number 2, and substitute all the C's with D plus 12, and 2 now has one variable. So your goal is to make a system of equation and take the equation and reduce it down to just one single variable. So what we're going to do is we're going to substitute 1 into 2. So we get everywhere there's a C in 2, we're going to replace with D plus 12. So we get D plus 12 minus 5 plus D minus 5 is equal to 28. So let's simplify this down. So 12 minus 5 is 7. 7 minus 5 is 2. And we have 2D on this side, 28. 28 minus 2 is 26. Divided by 2 is 13. So D is 13. Means David is 13 years old. And now all we have to do is take this David value and plug it back into equation number 1, which was C equals D plus 12. So to find Cameron's age, we can just sub in 13 plus 12 is equal to 25. And there it is. We found Carmen's age. Sorry, not Cameron. Carmen's age is 25. And so let's do some more examples. Hopefully you guys got that right. Adam is 20 years. Let's remember A for Adam. I'll just use the first letter of their name. It makes it a lot easier. And B for Brian. Adam is 20 years younger than Brian. What does that mean? Adam is 20 years younger than Brian. It means Brian is Adam plus 20. Right? Brian is 20 years older than Brian. In 2 years, Brian will be twice as old as Adam. 2 years, Brian will be twice as old as Adam. It means B plus 2 was equal to twice as old as Adam plus 2. Twice as old as Adam plus 2. right? Be twice as old as Adam plus 2. So pretty straightforward. So let's label these as equation 1 and equation 2. And let me just double check that we've gotten it right. So Brian is 20 years older than Adam. And in 2 years, Brian will be twice as old as Adam in 2 years. So let's sub 1 into 2. So wherever there's a b, let's substitute it. So 2a plus 2 is equal to 8 plus 20 plus 2. And let's simplify this down. So you get 2a plus 4 and a plus 22. And let's move the a over. So a is equal to 22 minus 4. And Adam is 18 years old. So now all we have to do is go back to equation number 1, which is b is equal to a plus 20, and sub in a, which we have 18 plus 20, and we get 38. And Brian is 38 years old. Now let's do one more to really solidify the understanding. This one's slightly more involved, not really. So the sum of ages of Nicole and Kristen is 32. In 2 years, Nicole will be 3 times as old as Kristen. How old are they now? This means the sum of ages of Nicole and Kristen is 32. So n plus k is equal to 32. That's equation number 1. So what's equation number 2? In 2 years, Nicole will be 3 times as old as Kristen. So in 2 years, Nicole will be 3 times as old as Kristen. So n plus 2, Nicole in 2 years, will be 3 times as old as Kristen in 2 years. So we can do this in any order we want to do it, but let's do it this way. Let's substitute 1 into 2. So first, we see that unlike the others, this one's not even organized. So for fun, let's just solve for Kristen. So k is equal to 32 minus n. All I did was move the n over. And now let's substitute k into all the k's in equation number 2. So you get n plus 2 is equal to 3. 32 minus n plus 2. And let's simplify this down. So 3. 34 minus n. And let's simplify this down further. Sorry, I always forget to do the left-hand side. And this is 102 minus 3n. And let's simplify this down further. We move the minus 3n to the other side, we get 4n. And we move the 2 to the other side, you get 100. And n is equal to 25. Nicole is 25 years old. Now all we have to do is sub that back into equation number 1. N plus k is equal to 32. And we know n's value, 25 plus k is equal to 32. And all we have to do is 32 minus 25. And there we have it. Kristen is 7 years old. So hopefully you guys have started to see a pattern on how to approach these problems using the system of linear equations. And remember, this is generally the idea is if you have two unknowns, you need a minimum of 2 equations to solve them. And if you have 3 unknowns, 3, and so on. So to generalize this, it'd be better written as something along the lines of if you have n unknowns, so an n number of unknowns, you need a minimum of n equations. You can have more, but you must have a minimum. So from that, as per usual, I'll leave problems in the description below. If you guys liked, make sure you thumbs up, subscribe. Let's get to 20 subscribers. I'm pretty sure we're just a couple away. And I'll catch you guys in the next video.